In this podcast, we're going to look at more solving of quadratic equations. Earlier, we solved quadratic equations by factoring, using factoring a trinomial or unfoiling. This time, we're going to try two different factoring methods for solving quadratic equations. Let's recall the two methods we're going to use, by the way, are using difference of squares and grouping. And I'm going to start off with difference of squares because that's pretty much the easiest method for solving that you can use in a higher order equation. So let's take a look. Let's recall a little bit from the Difference of Squares podcast. A product of conjugates will always produce an expression called a difference of squares. And so a difference of squares will always factor into a product of conjugates. Now to see that, let's kind of remind ourselves by looking at this first example. If I want to produce this product or multiply together these two conjugates, and now they're conjugates because they're identical except for the center term, which are opposites, then I would multiply them together by the FOIL, and to get the first term, I'd just multiply my first terms. So I'd get 2x times 2x, which is 4x squared. For the last term, I'd just multiply my last terms. Negative 3 times positive 3 would be negative 9. And for my center term, I'd do an outside product plus an inside product. The outside product would be 2x times 3, or 6x. The inside product would be negative 3 times 2x, or negative 6x. 6x plus negative 6x, 0 for the center term, so I get the difference of squares, x squared minus 9. When you multiply together a product of conjugates, you always get a difference of squares, so there is no center term. Now, to factor a difference of squares, now this is a difference of squares because 25 is a square. 9x squared is 3x squared. So that's a perfect square. And so this is a difference, so this is a difference of squares, and it will factor as a product of conjugates. Difference of squares always factors as a product of conjugates. So I'm going to put two conjugates here. Their first terms will be the same, their last terms will be the same. The only thing that will be different is the center sign. So if I'm going to use two first terms that are the same and get 9x squared, it has to be 3x times 3x. And if I'm going to get a 25 with the same last terms, it has to be 5 times 5. And there I've shown my difference of squares factoring into a product of conjugates. Now with that in mind, let's do a type of problem that would involve factoring a difference of squares. The key is going to be two terms with a minus between them. Now in our first problem, it says, here are two terms, it says to solve this equation, but there's not a minus between them, there's an equal between them. But if I move the 50x to the other side, there'll be a minus between them. Then it'll read 18x cubed minus 50x is equal to 0. Now what's important to that is because anytime you're solving by factoring, you're always trying to use the zero product theorem. So you want a 0 on one side and you want to make a product on the other. But notice, even though this is a subtraction, it's not a difference of squares. X cubed is not a square, 18 is not a square, 50 is not a square. None of these things are squares. X isn't a square. So how are you going to solve it by difference of squares? Well, notice that they both have a common factor. 50 is 2 times 25. 18 is 2 times 9, so I can take out a 2. X cubed and x both have an x in it, so I can take out an x. And if I remove the 2x, I get 9x squared minus 25. For my two terms in the bracket. I check it to make sure it's right. I multiply back and get 18x cubed. I multiply back and get negative 50x. So I did remove the 2x correctly. And what remained is a difference of squares. 3x squared is 9x squared, so that's a square. And of course 25 is a square. So now I will factor the difference of squares. Now I got to remember to keep the 2x there. That's part of the problem, and it's part that I took out in the first step. Now I want to factor a difference of squares, so my answer will be a product of conjugates. So the only difference will be the center signs. If I'm going to get the same signs, 9x squared will come from 3x times 3x. 25 will come from 5 times 5. Now don't forget that it said that this was equal to 0, so put equal to 0. Don't leave out the equal 0. That's crucial. Now I'm in a position to use the zero product theorem. The zero product theorem says if the product of these three numbers is 0, then either the first number is 0, or the second number is 0, or the third number, 3x minus 5, is 0. And this leads me to the answer x equals 0, so that would be my first solution. This leads me to the answer x equals negative 5/3. That would be my second solution. And this gives me the solution x is equal to 5/3. And so this particular degree 3 equation has 3 solutions. Now let's take a look at the other subject of this particular podcast, which is solving problems in which we factor by grouping. Now, just as the indicator for factoring by difference of squares was 2 terms in this first problem, the indicator for factoring by grouping is going to be 4 terms. And I look at this first problem, and on the left are 4 terms, so I can factor that perhaps by grouping. It's certainly worth a try. I call this the first case the easy case. The easy case of grouping is the case where there's a plus in the middle. When you have that easy case of grouping, all you have to do to group this is group the first 2 terms together. So in one group I'll have 12x cubed minus 3x, and group the second 2 terms together, 20x squared minus 5. Now notice I've gone from 4 terms on the left to where there are now only 2 terms on the left. And in the first term, there's a common factor, 3x, so I pull that out. And I end up with 4x squared minus 1. And the way you check to see that that's correct is you multiply the 3x back and make sure you get what you started with. So 3x times 4x squared, 12x cubed. 3x times negative 1, negative 3x. The second term is composed of 2 terms, and it has a common factor 5, so I'll pull out the 5. And again, what's left is 4x squared minus 1. Now I still have a 2-term expression. My 2 terms are separated by that plus. And the 2 terms now have this bracket as a common factor, and notice the 2 brackets are identical, so that's exactly the same number in both terms. So I pull out my common factor, 4x squared minus 1, and what's left from the first term? Well, from the first term, 3x is left, and from the second term, plus 5 is left. And of course that's equals 0. Now as you solve these, always bring your equal signs straight down. Always keep a number both on the left and on the right. Never just have a number on one side with nothing on the other side. Continuing on, this second factor here is actually a difference of squares, 4x squared minus 1, so that's going to factor into a product of conjugates. And the only difference between 2 conjugates is the center sign, so one will be plus and one will be minus. The first terms have to be the same, and they have to give me 4x squared when I multiply, so it'll be 2x and 2x. The second 2 terms are identical, and they have to give me a 1, so it'll be 1 times 1. So now I have the 3 factors, 3x plus 5 times 2x plus 1 times 2x minus 1 is equal to 0. And so if that product of those 3 numbers is 0, then either the first number, 3x plus 5, is 0, or the second number, 2x plus 1, is 0, or the third number, 2x minus 1, is 0. And if the first number is 0, I get x equals negative 5/3. And I do that just by solving. I just subtract 5 from both sides, then I divide both sides by 3. And the second equation here, I get x equals negative 1/2. Move the 1 over to get a negative 1, then divide by 2. And in the third one, I get positive 1/2. So again, my third degree equation results in 3 solutions. And the reason I knew to do grouping was I started off with 4 terms on the left. Now in this next problem, I don't have 4 terms on the left, but I do have 2 terms on the left and 2 terms on the right. So if I took these terms on the right over to the left, I would be in the same position as the first problem. 10x cubed plus 5x squared minus 40x minus 20 equals 0. And I've now got a 4-term expression, so I can factor by grouping. I call this case the hard case. The hard case of grouping is where there's a negative in the middle. Now when I had a positive in the middle, the easy case, all I had to do to group it was to group the first 2 and group the last 2. That won't happen. That's not going to work here, I should say. If I just group the first 2, and if I just group the second 2, then without meaning to, I have actually changed the problem. In the original problem, it was negative 40x minus 20. If I have a negative here and I group the last 2 terms, and I distribute the negative 1 to make sure that I've grouped it right, I do get the negative 40x for the first term, but negative 1 times negative 20 gives me plus 20. So I get the wrong second term. So when there's a minus in the middle, you have to change the last sign when you form your groups. Now with a plus here, negative 1 times 40x is negative 40x. Negative 1 times positive 20 is negative 20, and this line is now the same as the line above it, and so I haven't changed the problem. Once again, I have reduced it down to 2 terms separated by this minus sign on the left side. Now the first term is composed of 2 terms, and it has the common factor 5x squared, so I pull that out. I get 2x plus 1 minus. The second 2 terms have the common factor 4, and I come up with, got a problem. Well, let's see, it's not such a great problem as it appeared. I just took out the wrong common factor. Instead of taking out a 5, you take out a 20. And I'm left with 2x plus 1. And it's real important that these 2 factors be the same, the 2x plus 1 be in both of these terms, because otherwise you don't have a common factor to take out on your next step. So here again I have 2 terms are separated by this minus. I have the common factor 2x plus 1 in both, so I get 5x squared minus 20 minus, or times rather, 2x. I think I'm doing this too late at night. Let me rewrite that. That didn't come out very neat. 2x plus 1. Now, what about this 5x squared minus 20? Well, it's not a difference of squares, but the 2 terms have the common factor 5. And when I pull out the 5, I'm left with x squared minus 4, and that is a difference of squares. So always be looking for that common factor to pull out. In fact, it might have been better if we pulled out the common factor 5, say on this step. Then we wouldn't have had this common factor 5 to worry about at the end. Okay, let's take a look at this second one. That's a difference of squares, so I'll factor it as a product of conjugates. X plus 2, x minus 2. The 2x minus 1 is, or 2x plus 1 is still there. Now, 5 times this times this times this gives me 0, so any of those 4 numbers could be 0. But of course 5 is not going to be equal to 0. We know that for sure. X plus 2 though will be 0 if x is negative 2. X minus 2 is 0 if x is positive 2. And 2x plus 1 is equal to 0 if x is negative 1/2. So again, for our 3-degree equation, we get 3 solutions: x equals negative 2, x equals positive 2, and x equals negative 1/2. Now there's one more case that you need to look at in the case of grouping, so I've held that for the next podcast. It's a borrowed podcast from another source, but go ahead and watch that and see what happens when you have a group of 2 terms, but the last 2 terms don't appear to have any common factor that you can factor out. That's in the next podcast. Take a look at it, and that ends this podcast.